Hey everyone, this is Tom Salemi of DeviceTalks. Welcome back to the DeviceTalks Weekly Podcast. This is a part one of a two-parter. So we'll be speaking with Doug Evans, the CEO and President of Lungpacer Medical. Doug actually was our first guest. Joined Kayleen Brown and myself on our first DeviceTalks Deep Dive, where Kayleen and I interview someone together about the challenges they faced in starting a company, building a technology, getting it commercialized, etc. So Doug was a fantastic first guest, amazing story, and we only got half of it, as Kayleen had joked during the conversation, and since that she really only got through one page of her questions. So we'll continue the conversation at DeviceTalks Boston. Doug will bring a couple of members of his engineering team up to talk more specifically about how AeroPace, which is Lungpacer Medical's product, how AeroPace helps patients who are on the ventilator it basically is a neurostim device that keeps their diaphragms from atrophying, which is a huge problem. And I didn't really understand it until I talked to Doug for our deep dive. So this conversation is really emotional and moving, and Doug was very generous with his experiences, which are awful. So I'm grateful to him not only for sharing his story on our deep dive, but also for being part of DeviceTalks Boston. I've got a secret about DeviceTalks Boston in a moment, but I did want to invite you to be part of DeviceTalks Tuesdays as well, which is happening this Tuesday. We'll have our old friends from S3 Connected Health back. Got a great case study, work with them to talk about how they help medical device companies develop connected health strategies. So make sure you register for that. So you can do that at DeviceTalks.com. And you can register for DeviceTalks Boston at boston.devicetalks.com. And the early bird rate that we have had in place is expiring on February 28th at midnight. But you, because you're a very dear podcast listener, have a couple extra days to register at that low rate. Use the code EARLYBIRD when you register, all caps, EARLYBIRD, and you will still get the early bird rate on March 1st and March 2nd. So thank you for listening to the DeviceTalks Weekly Podcast. We're really grateful, and we wanted to give you a little reward for tuning in to this particular episode, because again, it's a warm up of the conversation that Lungpacer will be leading at DeviceTalks Boston, which promises to be a fantastic couple of days of medtech discussion. So go to boston.devicetalks.com to register to attend DeviceTalks Boston. Go to devicetalks.com to register for DeviceTalks Tuesdays with S3 Connected Health, and that's it. We'll stop right there. I've got some comments about DeviceTalks Minnesota, which is happening on June 11th, which I'll share for the podcast and for my closing comments. So without any further delay, let's get this particular podcast started. Whoa, hold on one second. In the Newsmakers, I hate bad audio. For some reason, there was a scratchy noise when we recorded the Newsmakers. I was using my headset instead of my microphone. Maybe that was it. Might have been me. I don't know. But it can be heard a little bit here and there. So sorry about that. I hate bad audio. I know you do too. But all right, let's go. All right, you ready for this?
Ready.
Newmarker, how are you, sir?
Doing well, Tom. Doing well. How you doing, man?
Doing well. We are getting rained on today, so it's melting snow. So things are moving along. The seasons are changing.
Seasons are changing, yes. We're having unusually warm weather in Minnesota, actually.
So 20 degrees?
No, it's like 50.
Oh, well.
50. It's sunny outside.
You going up to the lake, are you?
No, wow, Tom.
Everyone can do a Boston accent. No one gives them crap.
I'm not going to do a Boston accent. I won't do that. That would be really bad. Ask not what your country. No, I'm not going to do that.
That's not even. We don't know. That's Hyanna. Anyway, so good. I'm glad you're having a warm stretch. We've got a fellow team member on the call today, Jim Hammerand, Managing Editor of MDO, Medical Design and Outsourcing. Jim, welcome.
Hey, Tom. Always good to be here. Thanks for having me.
You are representing the mighty Northwest. How are things there? Well, you need weather updates from the entire country.
It is a surprisingly sunny day here north of Seattle.
Nice.
Blue sky. We had a thunderstorm roll through this a few days ago, and it's actually my 3-year-old son's first time seeing lightning.
Wow.
And a cute little kid, he says, "Are the clouds scared?" And I said, "No, they're not scared." It's really fun. Growing up in the Midwest, I always used to see tons of thunderstorms, and now it's a family event. We get people together to actually see them when we can see them out here.
So, Jim, you're here not to give the weather, but to talk about your latest issue of Medical Design and Outsourcing. So, is it on the news, the proverbial newsstands right now?
Not in newsstands right now. It's live on our website. We've sent it out via email to all of our subscribers, and it is headed in the mail right now. This is our March 2025 edition, and it's all about minimally invasive med tech. We've had a big focus on this over the past year. A lot of interest from the medical device engineers and designers and other technical pros who read us, and so we devote this entire issue to minimally invasive med tech.
Take a moment to tell our listeners who don't know what does Medical Design and Outsourcing cover. I mean, the name is pretty descriptive, but why should they be reading your magazine?
Oh, sure, yeah. So our idea is we're trying to be a one-stop shop with medical device design, development, manufacturing expertise for technical folks at OEMs, but also at the contract manufacturers and suppliers. The idea being, we focus on collecting expertise from everybody in the industry to share, collaborate, and innovate together, trying to bring new and improved products to customers and ultimately to patients. So big focus on materials, components, manufacturing processes, everything that's new and exciting or new ways to use these things, looking really at how the major OEMs and groundbreaking startups are innovating, and then beyond that, what those experts might be able to share about what they learned in their work for the benefit of other readers who maybe are in the same space, maybe they're in just an entirely different part of med tech, but just gets those creative juices flowing or gives them uniquely useful expertise on a material or a manufacturing process.
And I know you've had the opportunity to talk to some of the major med tech leaders. You had Mike Busalam on a couple of issues ago. Or was it the last issue? And Lisa Earnhardt.
Yeah, January was
Abbott.
Leadership issue.
And so, and what I liked about the invasive approach was that I think you asked the question that we kind of always ask ourselves, like, what is minimally invasive? Like, because everything really sort of is minimally invasive in medical devices.
We would like it to all be minimally invasive, yeah.
What was your? Talk a bit about the survey you did with some of those medtech leaders to how they define minimally invasive.
It's funny. It started back when we did a webinar series last year in September, where I sat down with engineers who are working on minimally invasive technology, and we kicked off each live interview with that question. What is minimally invasive medtech, and how might your philosophy differ? And we started finding that there was some really interesting, design and development insights that came out of that. Everybody thinks about it a little bit differently, and I think the traditional thoughts are just surgical robotics, TAVR, things like that. But by asking that question we've been asking it of pretty much every engineer that I talk to, every executive I talk to, every doctor, anyone who's got their hands in this kind of work, I ask them, how do you think about it? And so for this edition, we pulled together a lot of their responses, and I'm just going to keep adding to that list online, I think, as more people come through, because, like I said, it's really, really yielding some interesting insights.
I just say, with that round of insights, I mean, where do you think that definition is moving in the industry?
Everybody focuses on the patients, right? Like, how much trauma are you causing the patient? How quick are the recovery times? What kind of complications are there? So the big trends are miniaturization. Big trends are, access through vasculature versus cutting somebody's head open or their chest open. But also some really interesting approaches as far as what are the total costs in healthcare, and are there things that you can do to reduce some of the, ultimately help the overall patient experience, and is that maybe a different way to think about minimally invasive?
I just think it's fascinating, actually just fantastic that there are so many things that it used to be you had to go into a hospital and get cut open to have done, and now this is more of going into a cath lab and having some kind of catheter delivered procedure. Like even something like, getting a heart valve deployed in your heart is becoming more of something that, in the past this was like, oh, you were going to have your chest cracked open, and now, this is, something that's a much less invasive procedure. And so that's kind of exciting, and definitely as, someone who's, kind of moving into middle age, it's good to see that kind of stuff happening. I'm looking forward to that, not.
Yeah, you talk about that. And, another great thing about minimally invasive is it really increases the number of patients that are eligible for some of these procedures where maybe they wouldn't be a good candidate because they couldn't withstand a more serious procedure. But, increasing that access, that helps patients. It also opens up new opportunities for medical device companies to find new patients to serve and new opportunities to get reimbursed for that. So, it's always helpful to think about that other side, too, about how you're expanding access for patients. And ultimately, it's good for the bottom line.
Fantastic. Well, what are some of the articles that people can find in this issue of Medical Design and Outsourcing?
We've got a walkthrough of Medtronic's portfolio. Jeff Martha earlier this year was talking about all of the high growth areas in their portfolio. And while he wasn't using the phrase minimally invasive very much, when you look at all of these things that he's talking about, from surgical robotics to the TAVR valves, renal denervation, which is, he said this could be the biggest thing we ever do, which is funny because we've got a photo on the cover of this teeny tiny catheter that goes inside. But what you talk about a big issue like that.
Big opportunity, yeah.
Really, really is. So that's our cover story. But then we've also got all sorts of technical guidance for the kinds of technologies that are enabling minimally invasive surgery, or minimally invasive procedures, I should say. So, high precision micro 3D printing, development advice for AI-powered medical devices. We've got some more nitinol know-how. I love nitinol, so we've got a little bit of information about processing that metal alloy. And then we also look at, how some of the major med techs are using it beyond Medtronic. So Johnson & Johnson, they use it in some of their cardiac ablation catheters. And then Flow Medical, a friend of the podcast, Jennifer Freed, her startup, they've got a nitinol-enabled system for pulmonary embolism. That's really interesting. We've got a first look. So we've got a lot more in the magazine. And then we're going to keep covering minimally invasive in a big way this year. Our minimally invasive webinar series that we launched in September, we're bringing that back. And
That's really
last year we
exciting.
featured engineers from Abbott, J&J, Synchron, and Diatix. It'll be similar feature on engineers from those major OEMs and groundbreaking startups. So if anyone here wants to go check out a replay of last year's series, or if they want to pre-register for this August lineup, I'll give you the URL. It's www.wtwh.me/minvasive. That's MINVASIVE.
Fantastic. All right. Well, we hope. So if folks are now coming to learn about medical design and outsourcing and want more of this issue, how do they subscribe? How do they get the email? How do they get the issue itself?
Go to medicaldesignandoutsourcing.com. We've got links there where you can sign up for our emails, and not just the medical design outsourcing newsletter that we send out twice a week, but we've got specialty emails on topics like nitinol, medical tubing and extrusion, all sorts of great topics. So just go there, sign up, get everything you can from us, and we'll keep you up to date.
Yeah, I'd really say, if Mass Device is the place where you go and get, the daily business news and insights about medtech. MDO is where you go, to get more of those deeper dives, on how is this stuff made, what goes into it. How is it distributed? That's really it's like, if Mass Device is your steak, then MDO is that baked potato and nice sautéed asparagus you need on the side to make this all well rounded. So
I think that's a good way to think of it. And actually, I think our first story that we're going to cover in the Newsmakers could be a good example of how the approach from both those websites.
Now you have me thinking about Manny.
Oh, yeah.
That was a good meal we had there. I think we did have some Were you channeling that Manny's meal? 'Cause that was,
it wasn't baked potato. There was that hash brown.
Oh,
that big thing of hash browns.
Oh, that was so
all
good.
the Minnesota people are probably like Manny's. Like,
all right. Well, let's. I ruined your perfectly professional segue, Jim Hammerin, but let's get into the
sorry,
news.
Jim. I'm sure Jim's been to Manny's. Jim went to the U. He went to.
I was more of a Murray's fan.
Oh,
I used to go
Murray's.
there for the steak sandwich
that's
when I
good.
worked downtown. Met up with some friends that also worked downtown. It was a good tradition that I very much miss.
Yeah, that steak sandwich was
Fantastic. All right. Well, let's roll on to the Newsmakers, Chris.
Newmarker's Newsmakers, and number 5 on the list, we've got some big news from Medtronic this week. Actually, a lot of news coming out of Medtronic, but they announced FDA approval of the BrainSense adaptive deep brain stimulation platform, which is really it's a first. It's something that they've been, really driving forward for a while. Jim, you just had a recent, took a closer look at that technology over at MDO.
Yeah, that's right. So at Mass Device, we covered the breaking news that they had won the approval. But at Medical Design Outsourcing, I sat down with one of the engineers who started working on this project 17 years ago.
Wow.
And we talked about what that development and design pathway was like. We talked about some lessons learned that other medical device designers and engineers might benefit from, and it's been a long haul, but it's very very encouraging what we're seeing, especially if you've ever had experience with Parkinson's patients and how debilitating it can be, and you see these deep brain stimulation devices switched on and the symptoms go away. This is really great technology to further automate those therapies to react to how the patient's doing in real time. And it took a lot of work, from software to better leads. And the biggest challenge was just how hard it is to sense those brain signals, especially when you're putting volts of energy into the brain at the same time to stimulate.
Oh, it's just fantastic. Medtronic was able to kind of overcome those challenges and get to this point, and now we have something that's FDA approved in the U.S. So this really seems to be big news in the Parkinson's space. This is out there now.
Oh, fantastic stuff! And I hope, fingers crossed, we'll have someone representing the technology at DeviceTalks Minnesota, which is happening on June 11th at the McNamara Center. So great start. Chris Newmarker, what's number 4?
Well, number 4 on the list, we have some more news out of Minnesota, which is Solventum, which was previously 3M's healthcare business, spun out last year. They announced this week they're going to be selling their purification and filtration business to Thermo Fisher for $4.1 billion. A lot of time when you see these, spin-offs like Solventum, or you saw the same thing with ZimV coming out of Zimmer Biomet. Those spun-off companies have a chunk of debt with them, and this kind of deal allows Solventum to kind of pay down that debt and basically get this kind of capital kind of move forward. And they're being led by Brian Hansen, who used to be CEO at Zimmer Biomet, and so now this, along with some reorganization they've been doing, kind of gets them set up now to move forward. And actually, we're talking on Thursday afternoon, and their earnings release and earnings call are going to be just in the next hour. So we'll see if there's some more news for them about where they're going to be going forward after this.
That's great. And of course, Brian Hansen left Zimmer Biomet to take the job at Solventum, and his successor Ivan Tornos is going to be our opening keynote at DeviceTalks Boston. Also this week will be chair. He'll be chair of Zimmer Biomet.
Moved over to chair of the board.
I think that happens in May. So lots of movement at Zimmer Biomet as well, and very happy to have Ivan Tornos at DeviceTalks Boston. All right. Well,
I tell you, DeviceTalks is where it's at. It's just it.
DeviceTalks Boston is going to be very cool this year, I got to say. Numbers look really good. We're way ahead of last year in registration.
It's going to be bigger and better than ever.
It's going to be a party, everybody. It's going to be a MedTech party. All right, Chris Newmarker. Ooh, number 3.
Number 3. Yeah, all that news last week of all those layoffs at FDA around Doge, and then there was reports coming out like over last weekend that some of those people all of a sudden got emails saying like, oh, like you come on back, So it looks like some of that at least was reversed over there. But I thought you had a good point on LinkedIn, Tom. Like you get something telling you're being let go and then you're coming back. I don't know if I'd be
not feeling great,
sticking around too long.
not feeling great.
Be looking
not
at the door.
Yeah. Again, it's good news for them, and someone else who was with the FDA had a great post as well, saying, "Look, if you want to go back, but if you're already down the road of looking at private industry, don't be afraid to take on those new opportunities." So I would give that same share those same insights with FDA folks, and I also put on LinkedIn, I want to know the story. Like, how did this get reversed? I have a hard time believing that it was just suddenly said, someone who did this suddenly said, oh gosh, golly, these people actually do provide a service that we need to have done, and reverse themselves. Someone went in there and twisted some arms and said, maybe it was the industry saying we're paying hundreds of millions in fees specifically. These aren't, I don't know what percentage of the folks are paid with tax dollars and what is it with fees, but industry is paying considerable amount to have expedited review, or as fast as possible anyway.
It's fee-based regulation.
That has to be considered.
Kind of the same idea. Like I have to pay if I need my driver's license renewed. Why should everybody be paying for the DMV? If everybody doesn't drive, well, like a lot of people are making medical devices. So
we'll see. And I saw somewhere else that some of the NIH funding was being restored as well. So
it's a work in progress.
No, but this isn't how you do this.
Yeah.
You take time and you analyze the situation and find where redundancies can be eliminated and efficiencies can be introduced. You don't just say, well, we'll cut you. They're treating this as if it's an app that is being recoded, and that these people are not, that they're just NPCs and not real people. It's not how real efficiency is acquired and how things should move forward.
When you're going to lose expertise along the way, and there are so many worries around these layoffs because they're especially like a lot of the people who are getting let go were doing work around artificial intelligence and stuff that was the future of the industry. So how are we going to advance the future of the industry if they don't know if there's no expertise to properly get stuff approved to move forward. So I don't know, Tom. What's next? I don't know. I know you're not Nostradamus.
No, I'm not going to get into that. I don't think this is. I feel I always kind of. I don't want this to be a political podcast, and it's not. And I don't think this is a political conversation.
For sure.
I think this is a conversation about process.
No.
This isn't about party politics or anything of the ilk or any personalities or the like. I think it's just doing what's best for MedTech. So, Jim, you're wisely silent over there in the third square. Anything to add?
Well, I will say if there's one good thing to come all of this, if DOGE is looking for wasteful, inefficient government spending, I believe they've got a budget of about $40 million for that DOGE, so maybe that's a good place to split.
Jim went there. Oh, yeah. All right, let's roll on to number 2.
All right.
On the Newmarker's Newsmakers.
Number 2 on the list. We have, Boston Scientific was pricing a $1.6 billion public offering, and it got actually like a lot of attention on Mass Device this week. And Tom, I think you were commenting on this on LinkedIn, and I think you hit on it, like that. One of the things that they were saying this money might be spent on was general corporate purposes that could pay for it, and goes through all these things, and it says and potential future acquisitions. So it's kind of like, all right, they're getting a little more money, or like another $1.6 billion, and some of this might allow them to to continue to go shopping. And Boston Scientific's had a lot of success in recent years, and made some notable acquisitions, and I think this is getting people interested that we're going to be seeing more.
Well, I had sort of alluded to what rumors I'm hearing, and maybe it's been reported somewhere, I'm not sure, but supposedly Boston Scientific has interest in returning to neurovascular. So this may be that, and who knows? I don't know. I don't know if the Cerenovus deal makes sense for them or not. but it could be something completely unrelated to that. But it's to our point. We're gonna be watching.
And a lot of Boston Scientific news this week. Actually, I mean, another notable thing was like them moving forward with a new catheter delivery system around FARAPulse, and that was something else. I mean, Jim, you're just on top of stuff on MDO. You were looking under the hood on that one as well. I mean, like, tell us a little bit about that.
Yeah, absolutely. So Boston Scientific, they said that they've had the first cases of this new investigational next generation pulse field ablation catheter. So it's not just for the ablation, but it's also for the mapping. It's called FARAFlex. And so, yeah, it works with that FARAPulse pulse field ablation system. And they're saying this is a really good next generation improvement. I talked with Dr. Brad Sutton, who's the chief medical officer of their Atrial Solutions business. And we actually had this interview scheduled for a while on a different topic, and then the day before they dropped this news, I said, hey, let's talk about this, because I love PFA catheters. So we've got some coverage of that at MDO about the design and kind of a first look at that, and there will be more coming out on that soon. But again, it's the PFA wars. They are heating up. Pardon the pun, although I guess it is non-thermal. And if you want a good look
heating
at
up,
that
but not
device,
the device.
yeah. If you want a good look at that device, you can go to Medical Design Outsourcing. Then I'm going to have a lot more for my conversation with Brad, talking about safety of PFA, comparative advantages, all sorts of good stuff.
Brad Sutton, of course, another friend of the pod. As you mentioned, we had him on back in December, and he was. I'm not very bright, but he was one of the people who could really explain pulse field ablation to me in an easy to understand manner. It was really a really great person to talk to. So, good guy. All right, Chris Newmarker, what is number
one? And this just came out this morning. We have Teleflex is going to be splitting up. They're going to be separating into two different companies.
Wow, they look so happy. I don't understand.
I know what splitting up. Why? They're gonna separate urology, acute care, OEM into a new publicly traded company. So there's going to be, for now they're using the placeholders NewCo and RemainCo in the news release. We're going to have, the RemainCo is going to be the vascular access, interventional, and surgical businesses. And they're looking to get this all done by mid 2026. So, we'll be looking out for whatever the name's going to be. I mean, Teleflex has been based in Pennsylvania. Is the new company going to be, where are they going to be based?
I like RemainCo. Let's go with that.
Just stick with RemainCo.
Better than OldCo, I guess. If we had NewCo.
OldCo, yeah. OldCo, NewCo. I mean, there was actually a ton of news today. I mean, this came along with their earnings report where they missed on revenue. Their CFO is planning to retire. They're buying Biotronics Vascular Interventions division for the equivalent of nearly $800 million. So all this news coming out. I mean, their stock, it's closing out the day here like over 22% down. I mean, that's like a fifth of the stock's value, down in one day. So that's boy.
That makes sense, though. I mean, it's a lot of uncertainty, and people are just like, you know what? I'm just going to hold on to my money for now and see how RemainCo and NewCo sort out. But it seems to be part of this wider sort that's going on in medtech. Yeah. I mean, you folks have been reporting on it all year long. I mean, obviously, we talked about J&J and Cernova's, Stryker and its spine business, Philips selling its emergency care business, Bioventus selling out its advanced rehabilitation business to a private equity firm. Some's going to private equity, some's going to corporate buyers. So, I don't know, there just seems to be a great realignment going on. At least maybe it's a recency bias and we're just seeing all these things happen. But it feels like there's a lot of redirection and consolidation kind of going on.
It's interesting when you've covered a space long enough, because now it's been I've been covering medtech
50 years, I think, right?
Like 50 years, yeah. It was in the Roosevelt administration when I started. Sorry about no. Anyway, I mean, there wasn't even really a medtech industry, and Teddy Roosevelt, it's writing about wood splints. Wood splints. You break your leg, wood splint. No, but I mean, maybe 10 years ago, there was all these mergers. I mean, Covidien, Medtronic, Covidien, Medtronic, all these, companies consolidating and coming together. And I remember people have been around the space for decades were kind of like, oh, this is like cycles. This happens. You have the companies all come together, and then they realize they're too big, and then you start to see spin-offs, and they're, it's kind of wild. I've been covering this long enough now. It's like, oh, here we are. This is we had the whole everybody's consolidating together, and now it's like stuff's like especially in times of a lot more uncertainty right now, the companies are kind of like, no, we need to be laser focused on something. We can't be just doing everything here. So you're all of a sudden seeing these spin-offs and them kind of divesting, and things are kind of getting sold off and moved into different areas, and fingers crossed it means more competition, and these smaller companies are more focused and have the resources to kind of innovate and get things moving forward faster.
Counterpoint, Jim Hammerand. Tell him why he's wrong.
But I agree with Chris. Sometimes you got to do it. You'll be in a better place. And, if they come out of this more focused, better to innovate. That's what it's worth.
Absolutely. All right. Well, great stuff. Folks should look for the new issue of Medical Design and Outsourcing. If you're not receiving it, go to medicaldesignandoutsourcing.com. You can sign up for newsletters and see the magazine and all the articles are up in digital form, right? For the issue. Right. Fantastic. All right, gentlemen. Thanks for taking part in the Newsmakers.
Always great to talk with you.
It was fun.
All right, folks, before we get into the conversation with Doug Evans, I just want to let you know this was a webinar. So it was, we had video involved. We probably had one slide. We didn't have we intentionally left it slide light. So we may refer to a slide or refer to attendees of the webinar who ask some questions. And that's what we're going to do with the deep dives. We're going to invite companies to come and present some slides and take some questions from the audience. So we'll be doing more of those. If you have interest in being part of that, shoot me an email at tsalemi@wtwhmedia.com. We're still feeling out the model, but we really think it's a great way to tell more medtech stories in a more interesting way. But all right, so again, we spoke with Doug Evans of Lungpacer. We'll kind of just get right into the conversation. If you want to hear the rest of the story, and if you want to let Kayleen get to the rest of her questions or hear the questions that she's asking, come to DeviceTalks Boston. Use the code EarlyBird if you're listening to this on March 1st or 2nd and foolishly missed our early bird rate. You can still get it because you're a beloved podcast listener. But we would love to see you in Boston. The numbers look great. And it should be a great couple of days. All right. So we're going to just roll right into the conversation that Kayleen Brown and I had with Doug Evans, the CEO and President of Lungpacer Medical. Doug, you're President and CEO of Lungpacer. We want to get into the Lungpacer story in a moment. But as always, we really like to understand the story of the folks we're interviewing and how they found their way into the medical device industry. Doug, what was your presence, your path into medtech?
Well, I started originally in my studies at Penn State in the mechanical engineering and the biomedical field. And I had really planned that I would ultimately initially go into the medical field upon graduation. But I ended up taking a little detour along the way, ended up starting in the aerospace business. And I entered a program at GE for management training. It's called the Edison Engineering Program, and spent 3 years working with them in product development, research, and then marketing and business development before ultimately I got back into medical devices.
How long were you in aerospace for?
So I was there for about 3 years.
Okay.
And,
yep.
Yep. And the sort of the tipping point for me was I was in a program that was a rotational program for management training, and my fiance at the time was a student at University of Pennsylvania, where I was going to graduate school at during the evening, and she had a classmate whose husband had a startup company, and they were looking for an engineer. They had 8 employees, and they were looking to bring on an engineer. And I thought that, wow, this would be exciting. I could get back to something I really had a lot of passion for. And I really hoped I would go into the medical device area just for a short period of time, get that entrepreneurial startup experience, and then hopefully bring it back into GE as I worked my way up the hopefully the leadership ladder there at that company. But it didn't happen. I got the bug for startup companies and never left.
Doug, I always wonder those who have experience outside of the industry and then they come back into med tech. Do you have one lesson from aerospace that you use still today in med tech?
Well, I think what was exciting for me in aerospace is that the missions are so big, right? I was excited when my first projects I worked on was for something called a radioisotope thermoelectric generator. And if you guys ever saw that movie, The Martian,
oh yeah,
where the astronaut goes and has to dig up this little pod from under the sand that heats. I mean, I actually worked on something like that. And what's fascinating is that you work on these projects that have such far-reaching possibilities across the universe, and they transport satellites and those types of things. And they also take years and years to plan. So you could work on something that would not see ever a launch for perhaps for 15, 20 years. And so I think the perspective I got from that is that great things sometimes take time, but when they do, you can have an incredible impact that can touch, so many people as it travels across the universe. So I think that gave me the opportunity to dream big, and I hopefully brought some of that passion into the medical device area.
I would think the medtech industry probably has a similar timeline. It's amazing to me how long people can work on a project. Yes. And ultimately, fortunately, we talk mostly about successes here, but I always wonder, like, good golly, you've been working on this for 15 years. Like, what if it didn't work out? I mean, that's a lot of time on a single project. But Doug, what were some of your successes in the medical device industry? We could probably spend the whole hour talking about your career, but high level, what were some of your biggest projects?
Sure. So, I think really my first one was probably the one that I'm most connected to. And it was the reason I went to this startup company. There was a group of innovators who were incredible mentors for me. They had licensed out a little technology to a company called J&J at the time. And J&J had just returned it because they couldn't figure out how to make this idea work. And the rest of the company, the other 8 people, were working on a rotational atherectomy device, which is essentially a catheter that can open up blocked vessels. And they were looking for an engineer who could just sort of pick this up. So I was a little intimidated, but I was excited because I was able to work on something that a major corporation wasn't able to accomplish. And, with the help from the mentors at the company and a couple of great consultants, we were able to take this product ultimately all the way to the marketplace. And it was a vascular closure device. It's known as AngioSeal. And the idea for it was to close these little holes in blood vessels that are only a couple millimeters in diameter, but they're formed after procedures like balloon angioplasty at that time, and now today stenting. But to close that wound, clinicians would have to have nurses or fellows place manual pressure on the groin area of the patients where the punctures form. And it was very uncomfortable for the patients. They'd have to have sandbags then put on. They'd have to be immobile for at least a day, and they wouldn't be able to go home for a couple days after those procedures. And so with that product, we were able to transform the way those procedures are done in that I've talked to patients who've had an angioplasty or a stent placed, and they can actually get up and walk out of the hospital an hour and a half later. So it was really great to be involved in a product from the idea stage, it's just a patent, all the way through the clinical testing to the product launch to seeing it impact patients. And so that was probably the most memorable product. And, it's still well used today. It's probably the most, I think it still has the largest market share all these years after its launch. Mm-hmm. And really, it has generated billions of dollars in revenue and been used in millions and millions of patients.
That's great.
What do you say to that except for boom?
So we're here to talk about the Lungpacer story, and the way we're going to build this conversation, just so folks who are listening will know, is we'll unpack Lungpacer, the company and the technology, talk about the engineering and about the manufacturing, and and ultimately about the commercialization path, which is becoming closer. But we want to, of course, start with the origin of the company as well, Doug, and delve a little bit into how you came to start Lungpacer and how the unfortunate way you really learned how necessary the technology was. Would you mind taking us back to Lungpacer's origins?
Sure. So in 2012, the company that I was working for was acquired. This is the first startup company I went to. I'd actually gotten to the point where we went from those 8 employees up to about 400 employees, and
wow.
Generating about 100 million revenue, shipping about 3 million devices a year. We were acquired, which is really incredible milestone. But at the same time, sadly, I'll pause for a second.
Yeah, sure.
My son got really sick, and he needed mechanical ventilation. And I saw firsthand how it was, on one hand, really life-saving for him, but also it was pretty harmful for him. And the good news is he ultimately was able to separate himself from the ventilator, which is a technical term they use called weaning. But sadly and tragically passed away a couple weeks later. So what I wanted to do after that happened, and with the exiting from my prior company because it was acquired, was to look for a way to sort of honor him. And when he was sick and he was in the hospital for many months before that point in time, he was an incredibly insightful, inventive guy, and he was always thinking about things that he could make better in there, whether it was, bigger wheels on IV stands so that when he walked around dragging his IV pull around, it would move better over the bumps in the hallway. But also, he had just other ideas. So I really wanted to honor I knew what he would want me to do. And I started out looking for ways to do that. And I was connected with a gentleman who had suffered the same type of tragedy with his mom. And he was a professor at the Simon Fraser University up in Vancouver. And he had this experience before my son Cameron did. And he had filed a patent, which was then held at an incubator in the Simon Fraser University. So I was able to meet this gentleman, Dr. Hoffer, and we talked about raising, a seed round of funding so that we could take this idea and see if we could quickly determine if it could really help patients, which we did. And we raised that first round in 2014.
Wow. Okay. Well,
yeah.
Thank you for sharing that with us. And I remember when we talked a few months ago, I had no clue that we all see, I think, ventilators as what they are, life-saving technology, and don't know the difficulties and the complications that come with that.
Yes.
What is it that makes the weaning so difficult? What happens physically that makes the transition off of ventilators so difficult?
That's a great question, Tom. And I think that was something, that both puzzled Dr. Hoffer and then even myself as we watched not only our own loved ones, but patients around them, try to get off of the ventilator. And, and truthfully, it wasn't really known until 2008 when a group at the University of Pennsylvania published a paper that was able to take biopsies from individuals that were on ventilation. And they published these results that the diaphragm muscle can atrophy at an extraordinary rate. You lose up to 50% of its muscle mass can disappear in a day or two, which is just extraordinary. And, the way I sort of try to wrap my head around that is that, there's really 2 muscles in our body that are always working. The diaphragm, which we're using right now as we're sitting here talking and taking a breath, and then our heart. And they work around the clock, right? Which is fascinating. They're always working. They're very different than our other skeletal muscles, like our arms and legs, right? We can go and sleep at night and we have no problem getting up and walking the next morning. Now, if we're in bed for a week or so, then we have that atrophy. But those muscles really are used to being rested most of the time. But the diaphragm muscle, because it's always active, just a very short period of time can lead to atrophy. And there was a paper that came out that said within the first hour, you can detect dysfunction in the mitochondria in the diaphragm muscle. And then that leads to very measurable atrophy over the next 12 to 24 hours. So that's the problem that we started out trying to solve, is how do we keep this muscle conditioned? And, I probably neglected to mention is that, when these patients go on a ventilator, it's really uncomfortable for them. Oftentimes there's some sort of an event that brings them onto the ventilator, which they're trying to heal from. And, they're sedated with medication to really help them find some peace, let their body heal for a period of time. But unfortunately, that sedation does eliminate the respiratory drive from the brain talking to the diaphragm. And it's good and bad. The good of it is that the body's not trying to fight the breath from the ventilator, but the bad is that muscle atrophies quickly.
Wow. So it's a remarkable story. Thank you for sharing it. And I wasn't aware that the reasoning wasn't known until 15 or so years ago, that this really is new discovery. But anyway, thank you for sharing, Kayleen. I know.
It feels unbelievable, to your point, Tom, that this problem has recently just been made aware of the industry. And I'm sick to my stomach thinking about the challenge you had to walk through, and you're still walking through, Doug. So again, thank you so much for sharing your story and helping us see that this is still a problem. I am a forever optimist. So what I see out of this is why I love medtech so much, because the innovators in medtech, they see problems that we don't even know are there. And I think about mechanical ventilation, and I'm like, oh, they have it all figured out. But they don't. So thank you for continuing to bring awareness to it and to do something about it. And I think that the first step for us as an industry to move forward with you is to walk into your shoes for a second and learn from you. So I'd like to really start at kind of the high level of the problem. So stimulating the diaphragm. And it's so much more complicated than just following a normal breathing pattern. And I'm sorry, my hands are shaking. I have a 2.5-year-old son. And it's hard to shift over to business when so much of our hearts are in this. So again, thank you for your bravery, and thank you for sharing your story. So let's go back to business, Kayleen, business. Stimulating the diaphragm. It's more than just following a breathing pattern. We're talking about an external stimulus that causes a reaction. So I have to imagine that there's some sort of a delay between sending an electrical stimulus to the phonetic nerve, and then when the stimulus to the phonetic nerve, and then when it reaches the diaphragm and it causes that muscle contraction. So there's got to be a delay in that. So how did you first reconcile that delay? And then is it the AeroPace software that synchronizes the patient's respiratory cycle so it doesn't interfere with the mechanical ventilation? So how did you rectify it? And then how did you translate that into AeroPace?
Terrific questions. Yeah, I think we had to learn, and we had to test the approach. And I give a lecture to a biomedical course at Stanford every year as a guest lecturer, and I start with asking, sort of identifying the problem for the class, and say, how would you solve this problem? And it's really interesting, they sort of follow the same path as we do as innovators and as entrepreneurs, of thinking about a lot of different ways. And, maybe, we start there. Ideally, you want the muscle to move, so you could directly put electrodes into the muscle and cause it to move. You can actually directly place electrodes onto the nerves themselves, or you can try to send signals from within the body to the nerves, or maybe even from the outside of the body. And we looked at all those approaches, and we really felt that using a catheter-based, essentially like a transmitter, on that can be easily placed at bedside was the best clinical pathway to use. And then we had to see, what is that delay? How can you synchronize that stimulation energy with the actual contraction of the muscle? And what was very exciting for us to find out is that we can quite quickly have that diaphragm muscle work. So those electrical signals transmit incredibly rapidly in the blink of an eye from the time we send them down to the diaphragm muscle. And what we do is we have a sensor that is on the mechanical ventilator, and we understand when the ventilator wants to give a breath of air to the patient. And so the ventilator starts to build pressure in essentially the airway tubing that goes in from the ventilator to the patient. And that process is actually much slower than sending an electrical signal. So we have a little bit of time. So as soon as the ventilator starts to pressurize the lungs, we can send the signal to the diaphragm and have the patient essentially breathe while that air is being pushed in from the ventilator. And so through time, we've been able to figure out how to synchronize that so that both actions happen together in a very healthy and beneficial way.
That's very helpful to understand. It might be easier for our audience to take a step back. And do you mind, Doug, sharing, when I said it's, not normal breathing patterns, but what does a mechanical ventilator do? I mean, the negative and positive pressure, and where's the problem with that? Just to help give context.
Yeah, sure. So the way we take a breath right now is we're sitting here. Our diaphragm is moving away from our lungs down towards our hips or our feet, depending if we're standing up, and that creates space, or essentially a vacuum, negative pressure around our lungs. That negative pressure allows that lung tissue to expand. And so there's no positive forceful pressure pushing air into our nose or mouth that fill our lungs. It's really the fact that the diaphragm moves away from the lungs themselves. So it's a very low, it's almost a no pressure system for breathing. But when the ventilator wants to give an air to a patient, the diaphragm is in the way. Essentially think of it pushing up on the lungs. The rib cage doesn't expand, so that stays there. The belly weight compresses down on the lungs, so the lungs are getting sort of compressed by all these tissues around them. And the only way to fill them up is by pressing a lot of pressure into the lungs themselves. And the goal of the ventilator is to get a certain tidal volume of air into the patient every couple seconds so that the CO2 can be removed and the new oxygen can be brought in. So it's a fundamental difference. Our device works with a negative pressure ventilation, whereas today's ventilators work with positive pressure ventilation.
Excellent. Perfect. Thanks, Doug. Yes. So I wanted to talk about the Lungpacer catheter and how it interacts. And I believe you have a slide that helps illustrate it as I go into it. If you don't mind, Amir, our amazing producer, if you would pull up that slide so we can see a live image. We'll get that on. Okay, perfect. So Doug, two-parter here. Can you explain what we're looking at? And then I want to go into the differences between a catheter, your standard CVC, and a Lungpacer catheter. So what are we looking at?
Okay, so you're looking at essentially an animation here of the catheter placement and what actually happens in a patient when the Lungpacer device stimulates the diaphragm. So what we have clinicians do is place the catheter either in the left jugular or the left subclavian veins. So these are not arteries, they're veins. And these are typical locations for the placement of central venous catheters. The catheter is then advanced, as it normally is, with the tip going down towards the superior vena cava, which is in the position that's shown in this animation. So there are two gray lines that go from the chin of the figure there all the way down to the diaphragm muscle. That's right. And it's so elegantly beautiful that when you place a catheter in either one of those veins and extend it down to the superior vena cava, that catheter will be millimeters away from both the left phrenic nerve and the right phrenic nerve. So by just using the highway of our cardiovascular system, we can advance a catheter that can get electrodes very close to those two nerves. And then our software system will figure out which of those nerves, there's 30, or which of those electrodes is closest to the nerves. And then when the system has determined that, we stimulate those nerves, and that causes the diaphragm to move down and out of the way, and then allows the lungs to expand and take the breath from the ventilator. And ideally, two things happen here is that the diaphragm can get strong if it's weak, and if it's initially strong and we use it early, we can keep the diaphragm strong. And then we also can help the lungs fill more naturally. And we believe ultimately, and we have an investigational device, which we're testing currently, we're gonna try to see if we can prove that we can mitigate lung injury that happens often from ventilation.
Excellent. So take us even more into the design of the catheter. So you had mentioned some of the standard CVC, the placement, it could be done by the bedside. What makes it, and you hinted to it, but what really makes it the Lungpacer catheter? What else is integrated into that catheter to complete this cycle?
Sure. So most of these patients are going to have a central venous catheter. They're in the ICU, critical care, they're on a ventilator. And these catheters are used every day to try to deliver fluids and medications. And it's important that they can deliver them rapidly into, the great vessels or into the heart of the patient, so it gets into their system quite quickly. So we didn't want to create a separate product or separate device. We wanted to really see if we could use that platform. Clinicians know how to place these catheters. And when they open up our kit, it looks exactly like a CVC, except it has a family of 30 electrodes on the surface of it, and there's an extra little plug that comes off the back of it that they connect to our Lungpacer controller. And so that allows it to do two things. It can be a central venous catheter, and it can also stimulate the phrenic nerves. So two things for one.
Excellent. So you mentioned, designing something so it's familiar. So arguably it's easier to be adopted. Did you have that same approach when it came to making sure that the ventilation system, or that the AeroPace was compatible with any ventilator? Is that how you initially approached it?
I think that was the initial goal. And to just go back on I think when the idea first came up for this product, most people would say, I have two nerves to stimulate. I'm going to need two electrodes to stimulate those nerves. And the early thought around this product was exactly that: two separate devices, one for the left phrenic nerve, one for the right phrenic nerve, and the clinician would just have to move them around until they could find those nerves. And then we had a very clever gentleman who's now our chief operating officer. He basically said, well, I'm going to sort of think out of the box here. We have two nerves, but I'm not going to just use two electrodes. I'm going to put 30 electrodes along the length of this catheter. And this one catheter, I could put it into almost any patient. And if I just put it in like they normally put in a CVC, no special moving it around, you just place it in there, one of those electrodes out of 30 is going to be near the left phrenic nerve, and one is going to be near the right phrenic nerve. And so there's no extra steps for the clinician. So back to your question of the idea here is really make it, the products fit the current clinical pathway, make it feel familiar for them, avoid it adding extra time, and ideally, eliminate another procedure, which we're able to substitute this in for the placement of a CVC.
Well, I'm going to round us home when thinking about designing it to talk about clinical trials. So could you give us a brief summary of the clinical trial status for AeroPace? And if you can you touch on AeroNova's ongoing trials? Absolutely.
So first thing that we can talk a little bit about is, so we have two different therapeutic modalities. So what I mean by that is the first group of patients that we set out to try to help were those that have been on a ventilator for 96 hours and had actually failed to wean. So these patients, we know they have diaphragm muscle atrophy. They're really at high risk for other comorbidities, risk for early death, and maybe never getting off of a ventilator. That's the group we studied. In that population, the way we used the Lungpacer device, which is our AeroPace product, was to exercise the muscle. So think about it as taking that muscle to the gym. And twice a day, the system will contract the muscle vigorously, like you're lifting some heavy weights, for about 120 contractions. And so we ran a series of rescue trials with that therapeutic modality. The other therapeutic modality is where we put this device in early, and we look to prevent diaphragm atrophy and also maybe see if we could help reduce lung injury. And have some other benefits, which we could talk about in a few moments. But in that application, we continually stimulate the diaphragm. So every time the ventilator gives a breath, we contract the muscle. So in one case, AeroPace, we do 120 contractions a day, but in AeroNova, there could be 25,000 contractions a day. So very, very different. And they each have different outcomes. So I could tell you a little bit about the results. So as Tom mentioned earlier, a long time, right? So first funding went in 2014 for our initial seed round, but we were really excited in December that we got FDA approval for AeroPace based upon a series of clinical trials. The phase 2 and phase 3 were both randomized studies. And the results were really exciting for us. We were able to show that we could get patients off a ventilation up to 3 days faster than the standard of care. We could reduce the risk of being on a ventilator by day 30 by about 35%. And we could reduce the risk of having to be reintubated or to go back on mechanical ventilation at day 30 by 60%. So all really helpful things, not only for the clinician themselves, the hospital for treating these patients, but really for the patient experience. Because it's tough being on a ventilator. It really is. Knowing what my son went through and seeing all the patients we enrolled in our study, it's not a great existence. When they do become aware of their surroundings, they have a tube down their throat. They can't talk. They can't eat food. Many of them, have nightmares, post-traumatic stress type kind of symptoms years after those experiences. So anything we can do to shorten that time is really exciting for us. So those are the outcomes from our AeroPace trial, which is great. And we'll look forward to getting that out to help patients hopefully soon later this year.
So encouraging and huge congratulations.
Thank you.
Yeah, for any medtech company, getting that news is welcome, but I can't imagine what your December was like receiving that nod from the FDA. What were your feelings at the moment?
Well, there were a lot of celebrations, that's for sure.
Yeah,
sure for your team. And, we just have an amazing group of individuals across all fronts, from the product development to the regulatory, the clinical, business strategy, our financial groups, quality, all aspects. Our team they really hung in there through this long period of time that it takes to bring these novel therapies to the market. And, it's challenging. Even, during the pandemic, we might have thought that it would be easy to enroll a clinical study, but it was quite the opposite because, the staff in the ICUs were so stressed. They were overloaded. People were working such long shifts that what happens is that clinical research goes down to the lowest priority, unfortunately. So even though we had a therapy that we thought, could be helpful, we couldn't run our clinical study. So that, stretched our timeline out a little bit. But it was a great December. So yes, a lot of celebrating into the end of the year for everyone.
That's fantastic.
Yes.
It's nice that you congratulate your team. I do want to, before we go on a little more, I do want to thank Sage Seymour, who's an engineer who stepped up to sort of help us prepare for this conversation. I'm trying to sound, I don't want to lump Kayleen into my own self-doubt, but
lump away.
Wanted to sound intelligent for once. So we got the help of someone who actually knows what they're doing. So thank you, Sage Seymour, for your support. This conversation so far, we've talked about the inventing the origin part of Lungpacer. Kayleen really did a great job breaking down the designing part. Manufacturing. What are the unique challenges to building a device like this?
Well, I think we set out with, trying to make a very novel, never before seen or used or tested device look a lot like something that clinicians are very comfortable handling every day. And that's really tough, right? Because, central lines have been evolved over 20, 30 years. They're incredible in they're an optimal design, the flexibility, all their features that they have. And I think for our engineers and our leadership, and certainly our Chief Operating Officer Viral, they just did some amazing things. They created a central line that also has all these other features on it. We have 30 individually addressable electrodes on the tip of this catheter. So it's just extraordinary. They could bake all of that in. And when a clinician feels the catheter, it's very flexible. It feels just like a central line. So it's quite remarkable what they were able to pull off. And I think they just added a very small, dimensional adjustment to the outer diameter, just increased the size a little bit. But it's really remarkable what they were able to pull off. But, the team evolved. And I'm always fascinated when I look at first of their kind products And then you look 5, 6, 7 generations later. What's really exciting is, that the first point is to get a product into the marketplace that works and helps the patient. And you can't always anticipate where it's going to end up, but it's exciting that new ideas continue to flow. And, I can't wait to see what the Lungpacer catheter and the system look like 10 years from now. It's really quite nice now, but it's going to continue to evolve and get even better. So I think that was quite a challenge for the team, but they really have done quite well, and they have some fairly sophisticated technology they use. So we make electrical circuits that have those electrodes on them, and we're using what's called flex circuits, and they're able to attach those to the outside of the catheter, almost like a candy cane spiral. And that process to do that, to have it reliable and durable and not affect the physical properties of the catheter itself, they're pretty extraordinary. And then to try to make the connections for those 30 electrodes within the hub of the catheter is absolutely amazing. And I still don't know how our manufacturing team is able to solder all those little joints. It's pretty amazing. So we manufacture that all. That catheter's done in-house here in our facility. Oh, wow. Outside of Philadelphia in Exton. And then we also put the control system together. So our team brings the boards in, the touch screens, assembles those, and then that goes on a stand. And so we assemble that here. My prior company is just a quarter mile down the road, and we were manufacturing, as I mentioned earlier, about 3 million devices a year. So there were a number of people who were willing to continue to work together on some new projects, and I was fortunate enough to encourage them to come join us here. And I have great confidence that they're going to be able to scale this device, in our current facility as we meet the demand for the product later this year.
Did you encounter some unexpected, I imagine you did, unexpected challenges during the manufacturing from the point of design to actually making the thing? How many adjustments did you have to make? What challenges did you have to overcome?
I'm incredibly spoiled with this group, honestly, Tom. They
I hope they're watching, because they're getting a lot of love today.
They do make it look easy. I am used to, and I'm knocking on wood right now, I am used to a lot more bumps in the road. So hopefully I didn't just jinx myself.
We'll knock as well.
But they're quite good. And, in the past, some of the products we worked on had, mechanical components. So if you think of like the Impella device, one of the prior catheters, which is very complicated for us, had a spinning internal component, 80,000 revolutions per minute. The tolerances, all the fits, all those pieces had to be so perfect each time when we made that device. And I don't want to say this is easy, but I think such thoughtfulness went into the design and the iteration of it and the pre-testing that they really worked out a lot of the challenges early on. So they're just really thoughtful, leveraging those experiences to try to avoid those pitfalls moving forward. So I'm quite pleased with how well it's gone so far.
Okay, great. Why don't we just fast forward to commercialize, Kayleen?
I was hoping you'd ask even sooner. Cannot wait.
I could see you just chomping at the...
Can't wait. Doug knows before we started that I said, can you help me narrow down my extra 10 questions? Then I refused to do so.
No.
So, let's start. I always like to start kind of at the macro view. Go-to-market strategies, commercialization, they have so many different elements, from reimbursement to training the physicians. So let's start with the market opportunity. Like, I understand the need. You saw a problem, a very personal problem, and you set out to try to solve that problem. But what does the market look like, and is there an opportunity?
Yes. So, it's a large number. I mean, there are about 2.5 million people each year, and just in the U.S., that require mechanical ventilation and are admitted into an ICU. About 38% of those, so a little under 1 million, will be on a ventilator for at least 4 days. And that is the population that we'll address with our first product. I think while some of them may wean naturally on that 5th day, there are a large portion that will be on day 6, day 7, day 8, and then there's probably about 10% of them that never ever wean. So there's this opportunity to help all these individuals along that spectrum with the hospital. And our focus is going to be to hopefully help this become a standard of care, that if a patient is on a ventilator at 4 days and they haven't weaned, that let's start rebuilding that diaphragm muscle and make sure that that's not a reason that they're still in the ICU on the ventilator.
Well, I'm going to walk us through your PMA, again, congrats, and reimbursement shortly, but you are in a really unique position where you received emergency use authorization in 2020 during the pandemic. So you sort of had a little taste of what it looks like on the market. Has that experience changed your initial go-to-market strategy?
What was really interesting is that, and FDA did an amazing job during the pandemic, just based upon what I saw, on our interactions with them and the number of emergency use authorizations they were able to get out there. They really pulled out all the stops, and particularly their respiratory group was tirelessly working, very late hours through weekends, really trying to get all these therapies out there. So we were quite fortunate to be able to do that. I think, our commercial experience, which, as I've spoken with other CEOs, was very similar, wasn't quite as optimistic and positive as you might think, because what we found is we had this emergency use authorization. So the next step would be to go to the hospitals and say, look, we have this authorization, but they still had their committee processes to go through. So they still had their checklist, and typically on their checklist is a published randomized control study that has outcomes that support the benefit. And we did not have that. So, and many, many other companies didn't have that as well. I think from my view, the two types of products that did well with the emergency use authorizations really were the COVID test kits, and then also if you had a vaccine. And I think those were very meaningful, and those were really important. And I think people said, look, we've got to test, got to identify who has it, and then find ways to sort of to treat them. That being said, we had limited use. What we were able to do is where we had clinical trials running, and we had advocates that were in place and able to sort of push that through those VAC committees. We saw really good utilization, and we had a series of patients that were published in CHEST based upon the use of our product in COVID patients. And, we were quite encouraged to see that it looked like it improved outcomes and weaned more patients more quickly. And so what we saw was what we believe will be real world use of the ability of this device to really hopefully, have better impact and outcomes for patients.
That must have been a little bit of light in such a dark time.
Yes. Yeah, it was. I think, if I had my wish, we would have been 2 years further along our development cycle, 2 or 3 years, and been able to really help a lot of patients. There's a story I always tell when we got our IDE approved for our clinical trial. So this is our Rescue 1 study, the first of 3 studies. There's a patient at Dallas, it was our first clinical site, who was on a ventilator for several weeks, wrote a note to the doc, said, pull the plug. I'm done. I've given up. I don't want to live on this machine. He couldn't eat, couldn't talk. And the doc said, wait, I've just got this new device approved. And he said, I can't guarantee anything, but let's give it a shot. Patient said no. Well, wrote a note, said no, shook his head. The doc called his daughters, and they came in. They said, Dad, come on, don't give up. You've got to do this. And fast forward 2.5 weeks later, I'm at his bedside. A couple of our team members are at his bedside. He had enrolled in the study. The device improved his diaphragm muscle to the point that he could wean. And although he had the trach tube in for 5 weeks and he was rasping his words, he said, you guys saved my life. And he said, tears me up when I talk about it, but without you guys, we wouldn't have been able to do that. So the taste of what we got during the pandemic and what we saw during the clinical trial really lets me know we're going to change outcomes for patients, and we're going to hopefully reduce some suffering and really make a difference. And, in honor of my son, this is what we all set out to do. So yeah, really, really looking forward to doing that on a bigger scale.
And you're already doing it. And yes. that's the most validating, I think, part of this conversation is being able to look ahead, but then also look behind and see what you already have done. And that's incredible. So to balance out the hope, let's go with some challenges and talk about your PMA. So what are some of those challenges that you faced during the regulatory process for AeroPace?
Yes. Yeah. I think for us, You can't underestimate the challenge of enrolling studies in the critical care population. So I've run a lot of studies. Our teams have run a lot of studies in cardiovascular, surgical, orthopedic, spine. But when it really comes down to this critical care population, you get a lot of different patients. They could have had a car accident. They could have had a skiing incident. They could have just come from surgery. They could have pneumonia, COVID, COPD. So you're really treating a really wide array of patients. And what was great about our study was that we let all those patients in, but it was a very noisy study. So it required a lot of enrollment to get to the point where we could see that we were helping these patients and have significant outcomes. The great news is that the effect looks like it works across all those patients, which makes sense, right? If you're on a ventilator, regardless of what brought you there, and your muscles inactive, it's going to get weak. So a strengthening therapy should be able to help improve your outcome. But I think that's one of the takeaways that I have now. Now we're running additional studies, as you referenced earlier. Our AeroNova product is getting ready to start its phase 2 study. We're much more thoughtful as to how we design those and the types of patients that we include in, looking very specific and in a very narrow way, hopefully, on trying to get additional ways to help these patients.
Well, Rosemary G., one of our audience members, and I share the same next question for you. So we talked about the regulatory pathway. Let's talk about reimbursement. So one, what is your reimbursement strategy? And then the shared question is, what challenges do you feel that you might incur with the regulatory world? The reimbursement world.
Yes. So I've always been taught, from my mentors that, when you bring a product to the marketplace, you've got to be thoughtful to cost, as well as bringing a better outcome from the patient, the hospital, and then the clinician. So really looking at that, triple aim, quadruple aim, depending upon what you want to call it. We pursued a breakthrough designation early on. And what that does for us is that allows us to get a new technology add-on payment for our product, which we will have in place by October of this year. That will provide additional payment to the hospitals for using our device. And then when we designed the clinical study, we also created outcomes that we measured, which we thought were very economic oriented. So for instance, less days on ventilation. You can translate that into dollars and costs for a hospital system, reduced need for reintubation. Those have implications for costs and also outcomes for patients as well. Fewer patients left on a ventilator at 30 days. That has cost implications. So what we're working to do is to translate those clinical measures into very tangible health economic value propositions for the institutions, so that not only will we be able to bring a new technology add-on payment, but we'll also show them, in addition, this is how it should improve your outcomes, your cost outcomes at your hospital. On top of that, we'll be pursuing CPT codes, which are ways for clinicians to get paid additionally when they use and they contact your product. And so ideally what we try to do is hopefully at the end of the day, we save the health economic system money and we make it advantageous for the clinicians and the hospitals to use our product.
Who is performing the procedure to who is implanting the device?
The device is typically being placed by the intensivists, and they'll usually run the initial therapy sessions with the product. For our future products, those could be other caregivers as well. So, our AeroNova product, which we didn't talk a lot about, that's going to be targeted towards hopefully having some benefits for surgical patients, for cath lab patients, as well as patients in the ICU. So that investigational device, is still, in the process of securing the additional clinical data, but we hope that will also then have applicability outside of the ICU and some of these other places in the hospital.
Well, Tom's question made me think of another question, Doug.
Okay.
So, we now know who's implanting it. So market adoption is so important about that usability. So how are you training them to effectively use AeroPace?
So we're gonna leverage a lot of the learnings from our clinical study, and what we found is that there are a lot of people that come across the product, and first of all, there are nurses that care for these patients every day, and they see the device working there. So we have to really make sure all stakeholders understand the value that the device and the technology can bring to those patients, and we have to make sure that they're trained. So, what we typically see is that after 3 or 4 cases, the clinicians are fairly well versed in using the technology. So part of our strategy for our commercialization will include clinical support people that will help make sure that the device is used properly, that all the stakeholders are aware of it and how to best use it, and that ideally that it sticks and becomes part of their clinical care practice at their institution.
There's not enough time, Doug. I wasn't kidding in our prep. There's not enough
She
time.
was not.
I still have 2 pages completely untouched.
Oh my goodness.
So I will circle
We're
back
going to
with
need
you.
another webinar.
Yeah,
Yes.
yeah, definitely. We'll do a week-long webinar. Take only 7 hours of your time. So the last question that I have for you is really just around fundraising. So where are you in your fundraising efforts, and what's next?
Okay. At JP Morgan conference, we had a lot of interactions with potential investors and strategics regarding our next steps. And we will be raising our Series C financing in a couple months. We're just getting ready to open a data room. I think we've got a really high level of interest in joining us in this mission to try to improve outcomes for these ventilated patients. And so, if anyone's listening and they know some great investors, we want to add people to our board of directors and, really get this company ready to, hopefully transform respiration and critical care for these patients, for the next 10, 15 years. We'd love to have you.
I'd like to echo Rosemary's comment. Please begin working with health plans now, as this is too phenomenal to not be covered. So, yes, we agree wholeheartedly. The technology is amazing. Your story is doubly amazing, Doug. Not only were you turned what happened into something that's going to ultimately help millions, I'm sure. But you're also really generous with your story, and you were kind enough to help us kick off our deep dive series. It's going to be a difficult one to top, but thanks, Doug, for being part of DeviceTalks, and you'll be at DeviceTalks Boston. So anyone who's listening and wants to meet Doug, come to DeviceTalks Boston, please. Kayleen, well, Doug, word to you, and then Kayleen, I'll let you sign off.
Okay. Well, it's been my pleasure, and I really love what you are both doing here. I think it's really important to give some time to all these innovations, talk about these devices. There's so many entrepreneurs. They can be motivated and inspired by many different things. I myself benefit by inspirational people that are around me and have gone before me. So I think that what you're doing is fantastic, and we need this is how things change. People sometimes are faced with tragedy, or they're observant enough to see a gap. And we need to help those types of individuals, make the change and create a better future for those generations that come after us. So thanks for the part that you're doing in it. And it's my pleasure to be part of this today.
Well, that is a wrap. Thanks so much for joining us on this episode of the DeviceTalks Weekly Podcast. Once again, join us at DeviceTalks Boston to enjoy part 2 of the Lungpacer Medical story. You can go to boston.devicetalks.com to register. And if it's March 1st or March 2nd, use the code EARLYBIRD so you get the early bird rate, which is expiring on February 28th at midnight Eastern. So we'd love to see you there, and I want to help you save some dough. So take advantage of the code. Join us on Tuesday for our Device Talks Tuesdays episode with S3 Connected Health. And of course, please do share this podcast on social media. Please do subscribe to the Device Talks Podcast Network. Please do connect with Chris Newmarker, Jim Hammerand, Kayleen Brown, and myself on LinkedIn. Find us there, connect. We want to be part of your future MedTech conversations. And I haven't really gotten into much of it, but Device Talks Minnesota, the agenda is up on the website, and we'll talk more about that at a future podcast. But we're lining up our speakers, so it'll be a great day of MedTech discussions. So much going on over here at the Device Talks in Device Talks land, and we'd love you to be part of it. So thanks everyone for being part of the Device Talks Weekly Podcast. We'll be back next week with another great episode.